This is my self-propelled motor. This is how it works, and I'm going to try to explain the statics and why it works. Inside this box, this orange box here, there are meshing gear teeth, planetary gear system. You see the pink gear in there is the center gear, and over here in this blue box there's an impeller. You can see it has blade vanes in it. The meshing gear teeth are between 4 and 8 times the volume of the impeller blade vanes once around, and as the impeller goes around once and you close this valve here, you close it a little bit at a time, the amount of volume that comes out of the meshing gear teeth increases, and it runs on suction, so it sucks the hydraulic fluid out of the reservoir as the meshing gear teeth continuously pumps fluid up to the reservoir at the same time. And since there's more volume in the meshing gear teeth, and this goes around once, you close the valve and more volume goes around the impeller than the impeller goes around. So that creates an aerodynamic force on the impeller blade vanes, creating a torque. You close the valve more and it increases the volume going around the impeller blade vanes. Once, twice, up to, since this is approximately 8 times, it can go around 8 times with the valve fully closed when the impeller goes around once. So that's a mathematical formula that I'm not going to get into here, but in the torque ratio, if you did close the valve all the way and this was 8 times the impeller volume, this would be 1 times 8 divided by 6, and if this was 1 here times 6, that'd be 48 at 1, and if this was 8, that would leave 40 times more force at 8, so it overcomes 8 with the valve fully closed. So you have to open the valve to keep it from accelerating. There's torque there. The head force, even if you add the head force, even the head force doesn't, there isn't much head force because it just fills the reservoir. But if you add the head force as if it were 8, it'd be 16, and still that's 16 is not equal to 48, and there's half is over here and half is over here, so they add an equal to 8, so it'd be 4 and 4 for each one, so it's still 8. The areas, the port areas, let me See if I can show you the port areas. No, it doesn't look like I can. Well, there are port areas in there, and the sum of the port areas was 3 of them over here and 3 of them over here on this plate, where the suction hydraulic fluid draws against this area plus this area, where these ports that go through here to the impeller. There's a ratio there that I can multiply into the equation on the suction part and try to make it greater than 48, and it still doesn't come out greater than 48, and I still get rotation. And I can make this impeller blade vane bigger and accommodate a bigger port area equal to the area of the sum of the ports in the meshing gear teeth, and make the meshing gear teeth longer in order to get the right ratio of 4 or however many, 6 or 5 or whatever I want. And that way the port areas will be equal and keep the radius the same, and eliminate that multiplier and keep the torque ratio the same. And I keep getting torque. I have been able to eliminate every prospect of what would make this motor not work. I can't seem to make it not work. I eliminated the pressure on the flow by dropping the areas of the lines as these areas of these small tubes come in. I increase the area to the sum of the areas, and except right here where the two come in here, I didn't double the area here, so it goes a little fast through here. The hydraulic fluid suctions, the head force comes in here and it suctions down here when the valve is open. That's off. All the hydraulic fluid suctions down through here and goes back. And here's the crank. Here's how you start it. This is the crank. You stick a crank in here and you crank clockwise. And then you close the valve a little bit and a little bit more, and it should begin turning. But since I only have a CAD model, that's all I can tell you. But there should be a sweet spot in there where it'll idle. Part of the hydraulic fluid will flow this way and part of it will flow to the impeller. But the meshing gears will still be producing 1, but since part of the hydraulic fluid will be flowing back, since the valve will only be partially open, this would be putting out 1, this will be putting out 1/8 suction, because 7/8 of the force will be flowing through the valve. And that would actually be stopped too, because you have to have a little extra force to overcome friction. So you'd want to close the valve just a little more. There'd be a sweet spot in there somewhere where it'll idle. But that's pretty much it. I'm sure that all the perpetual motion engines that you have ever seen and that have ever been made have either failed or failed to produce genuine results which would otherwise result in the industrial production of power. I would like to try and find out if this self-propelled motor will perform, and if it will perform at an industrial scale. This is a project made in the public interest, intended for the betterment of mankind. At this time, I have virtually no means to construct any mechanisms. To build a working model would require some precision tools which I don't have, and I don't intend to avail any of my own funds for any of it, since it is a project in the public interest. I will continue to abide without elements of production so long as the campaign is not fully funded. If the campaign becomes fully funded, I will invest in the necessary implements of production to pursue the project. With patience and persistence, I will be able to build this self-propelled motor, and if it works, I will be able to prove whether or not it will perform on an industrial scale. There's a school here in town that has a machine shop and a welding shop, and I may be able to avail myself of the use of their equipment, enroll in classes and make this machine. Thanks for watching. I hope you share this video with your friends, and don't forget to share it with the Indiegogo share tools. Be sure to look up self-propelled motor in the Indiegogo search engine. Thanks.